Good day everyone, this is Shockley Diode by the Electronics. What is Shockley Diode? Shockley Diode is 4-layer device. It conducts when it is forward bias and stops conducting when it is reverse bias. It is also called PNPN diode because of its construction architecture. This is the Shockley Diode's 4-layer device. Shockley Diode was invented by William Bradford Shockley, and that's why it is named after its inventor. Shockley Diode is operated only in forward bias mode. The major difference between conventional diode and Shockley Diode is it starts conducting when the forward voltage exceeds breakover voltage. Shockley Diode operates in two states, either on or off. Thus, it is used as switching device. Construction of Shockley Diode. It is formed by sandwiching 4 layers of semiconductors P-type, N-type, P-type, and one more N-type. 3 junctions are formed due to the merging of 4 layers together. Its construction and circuit symbol are described in the below diagram, like the two constructions shown. The construction of Shockley Diode can also be understood by 2 transistor model. The 4 layers constitute internally 2 transistors T1 and T2 connected together. The emitter-base junction of transistor T1 is junction 1. The common connected base and collector of transistor T1 and T2 respectively constitute junction 2. The base emitter junction of T2 is junction 3. When the diode is to be operated in forward biasing, then J1 and J3 are forward bias and junction J2 is reverse bias. When junction 1 and junction 3 are reverse bias and junction 2 is forward bias, the device starts operating in reverse bias mode. But when it is operated in reverse bias and the voltage exceeds the breakdown voltage, the diode gets damaged.
This is the Shockley diode equation. I is equals to Is, open and close parenthesis, E raised to Vd over N Vt minus 1, where I is the diode current, Is is the reverse current, Vd is the voltage across the diode, Vt is the terminal voltage, Vt is equals to Kt over Q, where K is the Boltzmann's constant, T is the temperature, Q is equals to electron charge. N is the ideality factor. This N is also called quality factor or emission coefficient. N is usually 1 to 2 and 1 is the ideal for the diode. Vt in the thermal voltage is approximately 25.856 millivolts at 300 Kelvin. Is not a constant and varies with temperature, so that Vd decreases and T increases. Under reverse bias, the exponential term in the diode is near zero, and the current is negative constant reverse current of Is. For a small forward bias voltage, the exponent ideal is very large and the negative 1 is neglected, so we end up in the equation of I is equals to Is e raised to Vd n over Vt.
Shockley diode as trigger switch. It is used to on the SCR or triggers the SCR in the below circuit. The RC network is fed to the DC supply and capacitor starts charging. When the voltage across the capacitor becomes equivalent to the breakover voltage of Shockley diode, the capacitor starts discharging. Then, the diode switches to on state and turns on the SCR by providing gate current to SCR. Shockley diode for turning on SCR. Thus, SCR is turned on and the alarm starts. When the voltage supply is ceased, then also the SCR remains in the latch, that is conducting stage for some time. Thus, the Shockley diode is only used for turning it on. Shockley diode as relaxation oscillator. In this, the capacitor changes through a resistor, and when the voltage across the capacitor is more than the breakover voltage, the diode turns on and acts as a short circuit. And then the capacitor discharges through the Shockley diode, and thus the cycle repeats itself. Voltage across capacitor. But the capacitor does not discharge completely. The waveforms of relaxation oscillator can be understood with the help of the diagram.
For this sample problem, given the Shockley equation, where Vt is equals to Kt over Q is equals to 0.026 volts at 300 Kelvin. Consider the given expression. Substitute the given values, 0.026 volts for Vt, 0.68 volts for Vd, N is equals to 1 and 9.75 times 10 raised to negative 14 ampere for Is in equation 1. So Id is equals to 9.75 times 10 raised to negative 14 E raised to 0.68 over 1 times 0.026 minus 1 is equals to 22.26 milliampere. Thus, the diode current is ID is equals to 22.26 milliampere. Substitute the given values. 0.026 volts for Vt, 0.75 V for Vd, and N is equals to 1, 4.85 milliampere for Id in equation 1. So 4.85 milliampere is equals to Is times E raised to 0.75 over 1 times 0.026 minus 1. Is equals to 4.85 milliampere over 3.371 times 10 raised to 12 is equals to 1.439 times 10 raised to negative 15 ampere. Thus, the saturation current is Is equals to 1.439 times 10 raised to 15 ampere. This is for letter A and this is for letter B.
Write down the Shockley model for the diode. If the operating range of the applied voltage is between 0 millivolts and 20 millivolts, Evaluate the minimum achievable small signal resistance of this diode. First, we write a given. Supply voltage is equals to 0 millivolts to 20 millivolts. ID is equals to IO times E V over N R minus 1. IO is equals to 10 negative 14. It is the reverse saturation current. VT is equals to 25 millivolts. It is the room temperature. V is equals to 0. ID is equals to 10 raised to negative 14 times E raised to 0 minus 1. ID is equals to 0. Small signal resistance is equals to NVT over ID equals, substitute to the equation, 2VT over 0 equals to infinity. So therefore high resistance at 0 volts. V is equals to 20 millivolts. Therefore, ID is equals to IO times E raised to 20 over 25 minus 1. ID is equals to 10 raised to negative 14 times 1.2255. From the analysis, to get minimum resistance, ID current should be more, so that V should be more, so that V is equals to 20 millivolts. IO is taken as room temperature. Therefore, minimum resistance is equals to NVT over ID. Substitute to the given equation, 25 times 10 raised to negative 3 over 10 raised to negative 14 times 1.2255 equals 20.39 times 10 raised to 11. Therefore, minimum resistance is equals to 20.39 times 10 raised to 11 ohms.